Now, we have many different algorithms for sorting arrays. The most popular ones that computer science students learn are bubble sort, selection sort, insertion sort, merge sort, quick sort, and so on. Now, these algorithms are often topics for coding interviews. So if you want to prepare for a job interview, I highly recommend you to study them. They're not that difficult. You just need to understand the pros and cons of each algorithm and how to code it in C++ or any languages. Again, I've covered them all in my data structures course, but in this course, we just want to study the bubble sort algorithm and implement it in C++. So I'm going to play the bubble sort video from my data structures course. Let's watch this together, and then I want you to implement this algorithm in C++. The first sorting algorithm we're going to talk about is bubble sort, which is the simplest of all sorting algorithms. Let's say we have an array of integers, and we want to sort this array in increasing order. With bubble sort algorithm, we scan the array from left to right, and if items are out of order, we swap them. So we start off by comparing the items at index 0 and 1. If the right item is smaller than the left item, we swap them because we want to sort this array in ascending order. So here, 2 is smaller than 8, and we have to swap them. Now we compare the items at index 1 and 2. Again, the right item is smaller, so we have to swap these items as well. One more time. Again, we have to swap these items. And one last time. Okay, this was our first iteration or first pass. We need multiple passes to fully sort this array. At the end of each pass, the next largest item moves to its correct position. So here 8 is in the correct position. This is why we call this algorithm bubble sort, because after each pass, the next largest item bubbles up and moves to its correct position. So in the next pass, the next largest item, which is 4, will bubble up. Let me show you. Once again, we compare the items at index 0 and 1. These items are in the right order because 4 is greater than 2. So we don't need to swap them. Let's look at the next 2 items. 1 is smaller than 4, so we should swap these items. And one more time. Again, these items are out of order, so we need to swap them. And the last 2 items. These items are in the right order, so we're done with the second pass. Now, 4 is in the right position. As you can see, our array is almost sorted. We just need one more pass to swap 2 and 1, and then our array will be fully sorted. So let's do that real quick. All right, our array is fully sorted. So here's your exercise. I want you to spend a few minutes and implement the bubble sort algorithm in C++. Then come back, see my solution. All right, we're going to define a function that returns void. We're going to call it sort and give it 2 parameters, an integer array and its size. Now, once again, if you want to support larger arrays, we have to use size t, but in this case, we can use int as well. It doesn't really matter. Now, in this function, we're going to iterate over this array and compare every 2 elements. If they are out of order, we're going to swap them. So for int I equal to 0, or we can start from the second element and compare it with the previous element. So I is 1, while I is less than size, then we're going to do I++. Now here we're going to check to see if numbers of I is less than numbers of I minus 1. So imagine we have 5 and 3. This array is out of order. So the second element, which is numbers of I, is less than numbers of I minus 1. So we need to swap these numbers. So how can we do that? Well, that was your very first exercise in the first part of this series, right? So if you have 2 buckets, apples and oranges, how can we swap them? Using a third bucket. So here we define a third bucket or a third variable called temp. Then we copy what we have in numbers of I into this variable. Now we can overwrite this with what we have on the other side, which is numbers of I minus 1. So we set numbers of I equal to numbers of I minus 1. Okay? Now we're going to grab what we have in our temp variable and put it into this variable. So numbers of I minus 1, we set it to temp. Now I would prefer to extract these 3 lines and put them in a separate function called swap. This makes our code more readable. and potentially we can reuse that function in the future. So let's define another function called swap that takes an integer array and two positions, I and j. So again, we're going to swap the elements or items at these positions. So we declare a temp variable and set it to numbers of I. Then we copy what we have in numbers of j to numbers of I. So numbers of I equals numbers of j. And finally, we copy what we have in temp in numbers of j. So numbers of j equals temp. Good. Now let's simplify our code so we can get rid of these 3 lines and instead call swap. We pass our array and I as well as I minus 1. Now, because we have a single line, we can clean up this code and remove the braces. That's better. So using this loop, we are iterating over this array and swapping the numbers that are out of order. But I told you that we need multiple passes because with every pass, the next largest item is going to bubble up and appear in the right position. So totally we need how many passes? If our array has n elements, we need n passes. So we need another loop here, an outer loop. We can call this variable I and then call the other one j. That's one way. Or we can call this pass. We set it to 0. And while pass is less than size, we just do pass plus plus. Okay? Now here we add braces and then move the inner loop right here. That is our bubble sort algorithm. Let's test it and make sure our implementation is correct. So I'm going to change the order of these numbers. Let's set it to 30, 20, and 10. Then we call sort and give our numbers and its size. Okay? Now let's loop over the numbers array and print each number. So int number in numbers. We print number followed by endo. Good. Let's see. So we get 10, 20, and 30. Beautiful. What if our array is already sorted? Let's make sure our algorithm still works. Take a look. Good. What if it's partially sorted? So we have 10, 20, and then 40 and 30. Let's try it one more time. Still good. What if we have an array with only 2 elements? Still working, great. What if you have an array with a single element? Perfect.